Hello. Oh, shit. Where'd it go? Oh. Okay. Just finishing up my lunch here, so I'm going to mute myself. Oh, put your name in chat. Oh, there it is. Here I am. Oh, God, cats. Hey! Got two cats that they're just now coming to the realization that they don't like each other. Oh, come. My stupid tablet isn't doing the way it isn't operating correctly. So I have to turn it off and turn it back on and see what it does. Any questions, y'all? Any questions, comments, thoughts? Please be sure and put your name in chat so you will be counted present. Go over here real quick. And oh, we're getting more and more people. Cool. So we're missing three
So I
people.
had a question.
Yes.
Are there any resources besides the YouTube channel to better understand the material?
Glad you asked. Let me. KhanAcademy.org is a wonderful website. They do more than just math. So they've been around a long time. And when I first came across it, they had just posted a geology lesson. So they do not only mathematics, they do all subject levels from K through college. And I think they're up to second year college. Some of the courses they're up into third and fourth year college level courses, but they definitely have pre-calculus in there.
Thank you.
Pre-calculus and calculus 1 and I think calculus 2 are considered first year freshman level courses. Cal 2 and Cal 3 are sophomore level. I took Cal 2 over the summer, and I gotta tell you this, taking a math course in an 8-week course is not good for retention. I'll tell you that right now. 90% of what I learned in pre-cal, I mean, in Cal 2, I have no clue. None whatsoever. So I'd have to reteach myself all that stuff. But Khan Academy is a great website. 60 Minutes did a bit on it a couple of years ago. The Bill and Melinda Gates Foundation. When they were homeschooling their kids, they saw this website and saw how good it was, and they went over there. It's out of India, the people who created it. And so they damn it, sorry, got distracted here for 1 second. Here we go. And saw everything they were doing, and they pumped a bunch of money into them. They had been a .com, and they were able to become a .org because of the support they get from foundations. And there's other websites. I heard about another one, but I forgot what the link was. So, and then in Canvas, there should be a link on the left-hand menu called BrainFuse Online Tutoring. Now, if you go on specific questions or stuff, they'll help you. But if you want to just look at overall, you have questions about things, Khan Academy is a good place to go. You want to relearn about factoring, because we're going to do a lot of factoring in this course. Khan Academy has plenty of things. Khan Academy also has a lot of interactive stuff. So it's just not a video. Sometimes you can find the interactive part where you go and you type in stuff or whatever. So Now I gotta try and get the PowerPoint open. It wouldn't open for me. Or oh no, it did open for me. Never mind. And I got that open, and I got the PowerPoint open, and there's Zoom. And so what I'm going to do now is go ahead and continue. Unless you have questions for me, I'll go ahead and stop this and answer any questions you may have. And let me see. Is it going to let me do it now? Yes, thank you very much. All right. Oh, this was the operations on functions where we're adding and subtracting and multiplying and dividing different functions. We already did this one, but I'll see about clicking through it again. So where we would add these, so we get the same denominator by multiplying this fraction by x minus 4 over x minus 4, and multiplying this fraction by x plus 3 over x minus 4. So the denominators are the same, and since we're adding, we do the distributive property in both cases, and then we're just adding the two numerators together. So if you're adding, you don't need to worry about changing signs. So parentheses aren't necessary in the numerator. And then you just combine like terms. Okay. And sorry. Sometimes you'd be done at this point because, and sometimes you can factor the numerator. And if I could have factored the numerator here, which you can't in this case, it doesn't factor nicely to nice numbers. Then once you factor it, you look to see, are there factors in the numerator that can go away with the same factor in the denominator? Okay. So the domain of f and g are those numbers in X that are in the domains of both f and g. So the domain of f excluded the number -3, and the domain of g excluded the number 4. So we have to exclude both of those numbers. Now, if there was something else going on here, then we would also need to exclude or limit more numbers. Okay. So not only do we look at the domain of the two functions we began with, we also look at the resulting function and looking to see, do we need to restrict the domain more? And in this case, we do not. Was it divide? Oh, we're dividing. Okay. So I'm going to do that over here. F of x divided by g of x. That's what this notation here means. F over g of x means we're going to take the f function. We're going to take the f function here and divide it by the g function. So in our case here, the f function is 2 divided by x plus 3, and the g function, which goes in the denominator, is x divided by x minus 4. Right? Sometimes this is all we need to do. Sometimes you can't simplify it, but this we can simplify because we're dividing by a fraction. You're dividing by the denominator, which means you need to change it to multiplication by multiplying by the inverse or the reciprocal, I should say, the reciprocal of the denominator. So this equals 2 over x plus 3 being multiplied by x minus 4 being divided by x. I gotta turn that light on up here. So overcast today, I need more light in the room. Okay. Now, the numerator and denominator don't have any common factors. So we would rewrite this as 2 times the quantity x minus 4 being divided by x times the quantity x plus 3. And we would, I don't know if they do the distributive property in this case, but normally I don't require you to do the distributive property. This would be the answer. This would be the end result. Okay, and that's exactly what they did here. Now we're going to look at the domain. Because we're dealing with the domain of F and the domain of G, again, we still need to restrict that X can't be -3 and X can't be +4. But now I look at this end result here and realize I have another factor in the denominator I need to be concerned with. So I can't have X equal to 0 in the denominator, because if I did, I'd have 0 in the denominator, because 0 times 3 is 0, and I can't have that happen. So the function does not exist at those 3 x values. These two, simply because we're starting with F and G, so those apply, even though I can use 4 here, but because I can't use 4 in this function, I can't use 4 down here, I can't use it. Because of the way it was originally written. So this is my domain. And notice I just tacked it on the end here. Whoops. And what they did, they put them in order least to greatest. That's fine. You don't necessarily have to do it that way. Because when you're listing numbers, it doesn't matter the order. So sometimes putting it in that kind of an order helps as far as seeing what's going on. If you put it in, what do you call it? Ascending order, in chronological order. But it's not necessary. Okay. Yeah, this is a summary. A relation between two sets of real numbers, so that the number x in the first set, the domain has is corresponding to exactly one number in the one number y in the second set, the range. A set of ordered pairs, x and y, in which the first element, no first element is paired with two different second elements. The range is a set of all y values of the function that are images of the x value in the domain. And then a function may be defined implicitly by an equation involving x and y, or explicitly by writing y equals whatever the function is. And this function notation is the y value. And the function is what happens to x. Oops. All right, unspecified domain. If a function is defined by an equation with no domain specified, then the domain will be taken to be the largest set of real numbers for which the equation defines a real number. So if we just talked about these two functions without stating what the domain is, then we automatically assume that the domain of f is all real numbers except for -3, and the domain for g is all real numbers except for 4. But sometimes they give you the domain. Sometimes they start out with a restricted domain. So like on f, they wanted all real numbers that aren't negative. So it'd be from 0 to infinity. All positive real numbers and 0. So sometimes we restrict the domain, and so you don't need to find out what it is. Yeah, they're mad at each other, so they take it out on my furniture. All right, function notation. F is the symbol for the function, X is the independent variable or argument, and Y is the dependent variable. F of X is the value of the function or the image of X. F of X is the Y value, which is the value of the function. So your ranges are the value of the function at a given X. So when you talk about the value function, you have to also talk about the X that gave you that value. And this will become more clear in a little bit. All right, the graph of a function. Identifying the graph of a function is a simple process, and then obtain of information about the graph of a function. Meant to make myself some coffee, but I didn't have time. All right. The famous vertical line test. Let me put it on get a thick line. So here's my X. And here's my Y. Put your arrows. And this is X and this is Y. And so when we talk about these things, if you look at a vertical line, this vertical line is X equals 2. That means every X value on this line is 2. And guess what? 2 goes to more than one Y value. So that means this vertical line is not a function. So if a vertical line intersects a function at more than one point, then it's not a function. And so this is saying the same thing, but using different words. Looking at it a little different. A set of points in the XY plane is the graph of a function if and only if every vertical line intersects the graph at most one point. So if a vertical line intersects the graph, but it only hits it once, and every single vertical line that hits the graph or intersects the graph, and it only intersects it at exactly one point, then it's a function. Right? So if we had y squared, which looks something like this, Okay. Every single vertical line that goes through it will only intersect it once. Right. If we did the graph of an ellipse, which looks like an oval, but it's not an oval, it's an ellipse. Okay. Every single vertical line that intersects it at more than one point. So it's not a function. It's a relation. We sometimes refer to it as a function simply as a matter of convenience, but by definition, it is not a function. Hyperbolas have the same situation. Hyperbola is a shape that looks something like this. Opposite facing parabolas that go either horizontally or vertically. So you have hyperbolas that go that way and hyperbolas that go this way. They're not functions because I can find at least one vertical line that hits it at least twice, or it will hit it twice, just like on this one. This type here, every single vertical line will intersect it twice. Here, it's a subset because there's some vertical lines that do not intersect it, and then there's some vertical lines that it intersected at exactly one point. There's only two lines that intersected at one point. A circle is not a function because boom, that makes it not a function because that vertical line hit it at two different points. So I think I beat that horse to death. All right. Here's on A it's a parabola in the Y. So this technically we could think of this as a function of Y, but when we're talking functions, for the most part, we're thinking about X. It's a function of X. This is not a function of X. Because as you can see, there's three lines that are shown here, vertical lines shown here that hit it more than once. Right? This is a cube root function. Well, every single vertical line will hit it exactly once. Okay. And this, yeah. Okay. Now, this is a hyperbola. The formula for a hyperbola and the formula for an ellipse are very similar. One has a minus sign, the other one has a plus sign. Hyperbolas have minus, ellipses have plus. And a circle can be thought of as a special case of an ellipse. Okay. And this letter D here is the absolute value function, the graph of the absolute value function. Every single vertical line will only hit it once. Now, each Y values, except for one of the Y values, will repeat once. So the Y values show up twice, but each X value only shows up once. Okay. Now, someday I'm going to learn to copy this and put it in a PDF file so I can use here. Now, finding f of pi over 4. Okay, I know it's hard to see, but here's pi over 4, and I go up to where it intersects the graph, and it intersects the graph at 2. So f of pi over 4 equals 2. Yeah, this is real basic stuff, but I got to tell you, there's people who misunderstand what they're asking for. So we go along the x-axis until we get to 7 pi over 4. And 7 pi over 4 is right here. And so we come down to intersect the graph of the function, and it graphs, so f of 7 pi over 4, it intersects the graph at a -2. So the x value is what you put into the function, the y value is what it equals. Right. And this is actually a sine function, 2 times sine of x. Okay. Now the domain, since we have a limited domain because it starts and stops, so all the x values it covers. So here's the lowest x value. The lowest x value is 0. The highest x value is over here at 2 pi. And it's all the numbers in between. So doing it in interval notation is like that. It's the interval from 0 to 2 pi, and it's closed at both ends. Now, if we were to write it and this is letter B, if we were to write it in set builder notation, so we're talking about the set of all x such that 0 is the low end, and x can equal 0, and then x needs to be lower than or equal to 2 pi. This shows the same range, the same numbers as this does. And when I was in high school and all through college till this is how we wrote it. We didn't use interval notation. My second time back to college is when I started learning about this. I find that very interesting. All right, letter C, we're talking about the range. The range is the y values. So I look in the y direction, up and down. How far down? So when we're talking about domain and range, we always want to start with the smallest number it can be. All right, so the smallest y value that is graphed. Well, the smallest y value is a -2. So it goes from -2, and what's the highest y value? Well, the highest y value in this case is +2. And it can equal those numbers. So again, it's going to be closed at both ends. So we use the brackets. And in set builder notation, we're talking about y now. So I'm going to use y in my set builder. It's a set of all y. The small end is -2. And it's going to be less than or equal to y, which again is going to be less than or equal to 2. So what this notation here telling me is that x can be bouncing up and down between -2 and +2, including the endpoints. Okay. Oh man. Sorry about this. This has been happening to me a lot. And I figured out why it was doing it. It's doing it because I'm hitting something on resting my hand on my tablet. The heel of my hand makes something happen that it takes me away. I haven't figured out what that is yet. And that's a C here. That looks like an E. All right, now letter D, the intercepts. It's saying list the intercepts. Since you're going to list the intercepts, you need to put down the ordered pairs, because they're not asking you to differentiate between x intercepts and y intercepts. They just want them all. So I always look for where it crosses the y-axis first, because if you have a y-intercept, you only have one, because it's a function. And that means you're only going to have one point on the the y-axis where x is 0. And in this case, it's going to be the 0.00. And it says list them, so I'm going to create a set. And so that's the y-intercept. So the x-intercepts is everything where it hits the x-axis. All right, 0, 0 is a y-intercept. It is also an x-intercept. But I already listed it, so I don't need to list it a second time. Okay. And so I just go left to right, and I write down the ordered pairs as I find them. And they were very nice to put them there. My lovely little cat is going to try and sit on my computer because it's warm. So it has, what is it, pi over 2, 0? And then the next one is pi 0. And then the next one after that is 3 pi over 2, 0. And the last one is 2 pi 0. And I close my brackets or braces. Any questions here? I have 5 intercepts. One of them does double duty, but I have 5 points that are either on one axis or the other, or both. In this case, I have one that's on both. So I'll move on to letter E. Someone tell me, how many times does the line y equals -1 intersect this graph?
Is it 4 times? No.
4 times.
Is that correct?
Yeah.
No.
Because, yeah, if I draw a horizontal line that goes right like that, it hits this graph 1, 2, 3, 4 times.
Okay.
Right? If I look at y equals -2, -2 only intersects it twice. Y equals 0, it intersects it 1, 2, 3, 4, 5 times. So it all depends upon what the horizontal line is, because sometimes it hits it twice, sometimes it hits it 4 times, sometimes it only hits it twice. All right. So you got to look and see where it's going to hit it. You will see a question like this on the test, and I guarantee you there are people who put down the wrong answer. So I don't want that happening. And in years past, there's been a surprising number of people who put the number down wrong or don't look at it correctly. Or I say, oh, that was 3 because that was the answer in the review, so it's going to be the same. No. Okay, for what values of x do you get f of x equals -2? F of x equals -2. So I want to find the x values that hit -2. So I want to look at where y equals -2, and I look for the x values that have that y value. So where are the x values that have a y value of -2? This is letter F. Come on. Well, first of all, how many times does y equals -2 intersect that graph?
Twice.
Twice. What are the x values of those 2 points?
Three is the first one, I think 3 pi over 4. Am I
3 pi over 4, and what's the other one?
7 pi over 4.
Done. Okay. And letter G, for what values of x is the function greater than 0? In other words, looking at the graph, over what intervals is the graph above the x-axis? So I'm going to try and get my graph is going to be a little bit more spread out than theirs is, but it's basically the same graph. It's just my scale might be a little different than theirs. Get this E out of the way. The closed dots at both ends means it happens there.
Sir, f of x equal, it just means 0. I mean, it just means y, right?
Say again?
I said, does f of x just mean y?
Yeah, the y values.
Okay, so it's asking for what values of x is y greater than 0. How
Right.
many? So, is it asking how many?
No, what numbers? And because it's an interval, so what interval contains all those x values where it's greater than 0?
I I
Well,
interval like both the can I take a guess? An educated
sure.
guess. Is it 3 pi over 4 by -2? Because that's the interval itself. That's the, well, not the line, but that's the actual graph that
Well,
tells.
okay. I'm gonna
Am
draw on the x-axis
okay?
where the function is above. All these x values in here and all these x values in here, everything is above.
Yes.
The function is above it. Those are the x values they're asking for. So
Okay.
it starts at 0 and goes to pi over 2. So we go from 0 to pi over 2 on that interval. But is 0 the y value for x equal to 0? Is it greater than 0?
No.
No, it equals 0. So it
Mhm.
won't equal this endpoint. So we use a parentheses here.
Okay.
And at pi over 2, is the y value with pi over 2, is that greater than 0?
Pi.
Yeah, that's this point here.
Oh, no, it equals 0.
It equals 0. So it won't, so pi over 2 is not part of this
Okay.
range or this interval. So we use the parentheses.
Okay.
All right. And then we do union. because we have more than one interval, so it's going to be, so we look at what's this point here. This point is pi, and this point here is, I mean, this x value is 3 pi over 2. So the next interval is it's gonna happen this exact same way, because at pi it is 0, and at 3 pi over 2 it is 0. So we don't include those values, but it's everything in between them. So again, we use parentheses, and it's going to be pi, comma, 3 pi halves. Whoops. All right. So they're going to go through, and we'll look at it. Okay. So f of pi over 4 is 2, which is what we got. And f of 7 pi over 4 is -2, which is what we got. To determine the domain, we notice that the points on the graph have x coordinates between 0 and 2 inclusive. And the word inclusive means 0 works. 0 you can use in the function, and 2 pi we can use the function. So it's everything in between those.
Sir, what does the U symbol mean in letter
Oh,
G?
the U, that means union.
Union.
So it's everything in this set of numbers and everything in this set of numbers together.
Together or between?
No, together.
Together. Okay.
Because between pi over 2 and pi, we're not including those numbers.
Okay. Okay, I understand.
Okay.
Thank you.
The U stands for union. And union means is like adding. You're just putting everything together. So it's everything from this bucket and everything this bucket together. And so they gave for letter B, they gave it in set builder notation and in interval notation. In MyLab, they will if they want one or the other, they'll say put it in interval notation, or they'll say sometimes they'll ask for both. So they'll ask for the interval notation, and then they'll ask for set builder notation. They'll ask for them separately, but it'll be like this. Okay. And this one is about the range. So we look at the lowest Y value versus the highest Y value. And so it's everything between -2 and +2. And we use the brackets because it can 0 and -2 and 2 are part of the graph. And then they showed the two different ways of showing it. Letter D, they listed the points. And they listed the exact same points we had. All right, so drawing a horizontal line through there, and you look at where it intersects. Right, and they didn't list the points because that's wasn't what they were asking for. They were just asking for how many times. What's wrong with me? And
what's the difference between the brackets and parentheses?
the brackets means it can the endpoints are part of the set.
Okay.
The parentheses means it's a boundary point, but it's not part of the set.
Okay.
So as you're coming towards 0 from the positive side, okay, so as you're approaching 0 from the positive side, it's all those numbers, but once you get to 0, we don't include the 0. And as you come up towards pi over 2, it's all these numbers coming up to pi over 2, but not including pi over 2. So that's why we use the parentheses to show it doesn't equal, and we use the brackets to show that it can equal. Okay. Since there are only 2 points that have -2 as a y value, then those x values are the x values that give us -2 in the function. So that's these points. Okay, I listed them as a set. You could just list them separately. You don't need to put it in set notation. And I like their graphic here because in yellow, it's above. So where is it above? Well, it's above between these two numbers, but at those two numbers, it does not equal 0. And same thing here. So that's why I have it this way. That's how I wrote it. Or you can use in inequality notation. Union can also be thought of as the word or. X is either in this interval or X is in the other interval. X is inside this inequality or X is inside this inequality. So that's just giving us two groups of numbers that X can come from. All right, the zeros of a function. The zeros of a function are the same as the x-intercepts. If the graph crosses the x-axis, where it crosses the x-axis is an x-intercept. What the value of x that makes the function equal to 0 is the zero of a function. It just so happens that those two numbers will be the same. So the zeros here are exactly the same as the x-intercept values. The x-intercepts are the 0, the pi over 2, the pi, the 3 pi over 2, and the 2 pi. Can't stress it enough. X-intercepts and the zeros of a function are the same numbers. It's just you're looking at it differently. One way you're looking at as a value for the function to give it 0, and the other way you're looking at the graph. Where does it cross the x-axis? Okay. Yeah, the zeros of a function are the x-intercepts of the graph of the function, because the x-intercepts of the function are shown and it lists the x-intercepts, so those are also the zeros. On the test, the first test, you'll be asked these two things separately. you'll be asked for I will ask you to put down the x-intercepts. And a little bit later, I'll ask for the zeros of the function. Those two answers should be the exact same. Okay. So if you get one right, you should get the other one right. All right, so here we have a function. This is called a rational function because it's a fraction. Rational means you're having fractions. And rational functions are when your numerator and denominator are polynomials in x plus 3 and x plus 4 polynomials. Well, find the domain. Well, you have a fraction. What number is restricted from the denominator? Because whenever you have a fraction, a over b, you always have the restriction that b can't be 0 because dividing by 0 is undefined, and where it's undefined, the function does not exist because we can't use 0 in the denominator. So in this case, the denominator is x plus 4. So if I find out where that makes it equal to 0, then that tells me what I need to restrict, what I need to keep out of the domain. Well, solving for x gives me x equals a -4. So my domain, and it's just easier to use set notation here, is all x such that x is not -4. Boom, done. Yay. Now, one way to solve this is that saying that x plus 4 cannot equal 0. And so x does not equal -4. So we're done. We have it. We put that in the set builder notation. And all is right with the world. If I wanted to do interval notation, and I don't think they require you in this case, but I would put down a number line and put the number -4 on it. It's everything below. So I'm going to put a parentheses here, opening towards the left, because it comes from -infinity, comes up to -4, but it doesn't include -4. And then it jumps that little spot and it starts on the other side and keeps going this way. So I have two intervals, one below -4 and the other one above -4. The low and intervals is lowest to highest. The lowest here, that means it's going towards -infinity. So it's the lowest here is -infinity, and it comes up to -4, and we never reach infinity. Infinity is a journey. It's not a destination. So it goes on forever in that direction. It comes up to -4, but can never reach -4. And then it starts on the other side of -4 and goes towards positive infinity. And again, we have parentheses because the endpoints are not part of the set of numbers. And then we go do a union because it's x is either here or it's over here. So that's why we do the union. And so these are the two ways of showing it. I don't remember how they do it. Doesn't matter. Anybody got an idea on how to answer letter B?
Just plug in X and Y.
Yeah. Well, and since you have the function f of x equals x plus 3 divided by x plus 4, you want to put 1 into the function. So that's f of 1. What this means, I'm going to replace x with 1. So this x becomes a 1. So that's 1 plus 3 in the numerator. And in the denominator, I wind up with x plus 4, which gives me 4 divided by 5. So the ordered pair for 1 is 1, 4/5. This point is on the graph. This point is not. Because when I put 1 into the function, I did not get 3/4. If I put 0 into the function, I would get 3/4. But 1 does not give me 3/4. So 1 3/4 is not on the graph. This was letter B. If x is 2, what is f? And what is the point on the graph? Well, you put 2, you find out what, letter C, you find out what f of 2 is. What'd you get for f of 2? Put 2 in for f, put 2 in for x. And what do you get? Did someone get a number? You'll get a fraction. Don't punch the fraction into a calculator. I want the fraction. What's 2 plus 3? What's 2 plus 6? I mean 2 plus 4. I gave the answer.
5, 6.
Yeah, so you have 5/6. What's the ordered pair? What's the point? The point is the ordered pair that is created. The x value is, and the y value is. Boom. Okay. So now we have us on letter D. It is different than letter C. Letter C, you want to find out. You have a specific x value, so you want to find a specific y value. In letter D, you're given a specific y value. So you have f of x equals 4. So just like in number 2, I mean, letter E, you put 2 in for x. Well, on letter D, you have the x plus 3 divided by x plus 4, and that's supposed to equal 4. F of x equals y. Y is 4, and f of x is this expression. And then you just solve for x. Multiply both sides by x plus 4. So you get x plus 3 equals 4 times x plus 4. Please use the distributive property appropriately. Do not abuse it. You'll get punished for it by losing points. Okay, so you have x plus 3 equals 4x plus 16. Right? 4 times x, 4 times 4. I want x on one side. The textbook would have you do this differently than I did. But I would subtract x from both sides. The reason I'm subtracting x from both sides is so that my x has a positive coefficient. So I don't have to worry about dividing by a negative number. That's just how I do it. So you wind up with 3 equals 3x plus 16. Now I want to get rid of the 16, so I'm going to subtract 16 from both sides, because negative 16 and positive 16 make for 0. And so that disappears over there. So all that's left is the 3x. And then 3 minus 16 is a negative what? 13? or negative 16 plus 3 is still the same as 16 minus 3 with the negative sign. And now we divide both sides by 3. So now my x is going to equal the negative 13 being divided by 3. And so here's my x value. That gives 4. Okie doke. And then that was letter B. Letter E, I'm going to put that one over here. Letter E is what are the x-intercepts? So where does the function equal 0? The x-intercepts is where x plus 4 being divided, is it plus, no, it's plus 3, sorry, divided by x plus 4. Or when you have a rational function like this, all you need to do is set the numerator equal to 0. Because if I multiply both sides by x plus 4, all I get is x plus 3 equals 0. X plus 4 times 0 is just 0. And then that just leaves that. And so we get x equals a negative 3. So negative 3, 0 is the only x-intercept. Okay. Or negative 3 is the x-intercept. If you're going to call it the x-intercept, all you need to do is list that value because you know the y value is going to be 0. Notice they said, if any, because sometimes you don't have x-intercepts, just like sometimes you don't have y-intercepts. With x-intercepts, you can have more than one x-intercepts. But with y-intercepts, you can only have at most is 1. What are the points on the graph? Well, I already here. That's the answer to that one. Now, the y-intercept, how do you find the y-intercept? Someone tell me how you find the y-intercept.
Put 0 in for x.
Exactly. Because the y-intercept is where it hits the y-axis, and the x value on the y-axis is 0, so you put 0 in for x. So putting 0 in for x, you get 3/4. Because these x's go away because you put 0 here and 0 here, so you have 3/4. But that's not one of the questions I asked. There we go. The domain, same domain I have. When x is 1, you do not get 3/4, you get 4/5. So is not on the graph. So this would be your answer, this right here. And this is the work supporting it. When x is 2, then you just put 2 in the function. And it's 2 is the x value, and what you get out of the function is the y value. And yeah, we put 0 in for y, or the f of x is the 4. So yeah, they set it up the exact same way I did. They solved it. Okay. And so when x is negative 13/3, we get 4. So that means the point is, and I didn't write the point down. Okay. And they solved it pretty much the same way I did. Okay. Average cost function. I don't know why they throw the average cost function at us. And they use the wrong notation here. I will tell you that. No, they don't. It was a different textbook. They used the wrong. Whenever you see a bar over a number and it equals a value, chances are it's about the average or the mean. Okay. So that means we divided the cost function by X to determine how much it cost per unit. Okay. Each unit is a drone. So if I multiplied this equation by X, that would tell us how much it cost to manufacture X number of drones. Right? And if I manufacture X number of drones and I divide that number by X, that'll tell me how much each one cost. Okay. And so what you do here to find the cost, the average cost, in other words, how much did it cost to manufacture one drone? If I manufactured 10 of them, how much did it cost per drone that day? And so I put 10 in for X and calculate it. All right, for 20 drones. So I put 20 in for X and calculate it. 30 days and on down. And so that, and then they want you to graph this so that you would use a graphing calculator. I do not test the use of a graphing calculator. So I kind of gloss over those, but create a table. Okay. Oh, we're talking about minimize cost. Minimize the average cost. That's the reason, one of the things you do in if you were take business calculus, that's one of the things you would find. Take the first derivative and find out where that's zero. Okay. But so we put 10 in to the cost function and we get $1,940.20. Put 20 in, you get $1,200.20. So the cost per drone went down. If it was, what was the next one, 30? Then the cost per drone dropped down just under $1,000, $933.53. Now, for the average cost function, you would put, you'd put, let me back up here. You would put this function into the cat for letter D, you would put this function in for X into like in the graphing calculator, y sub 1 of X equals, and then you would type that function in appropriately. Okay. And then you would go in and do the window setting and change your window setting for X, where X is the smallest X value is 0 and the largest X value is 60. And notice they didn't say X equals 0 because I can't put 0 in the denominator of this fraction, so it wouldn't work. You'd get an error. And then for the next one, you look at the table and you look at, you scroll through the table in this portion. And so you're looking at the number that gives you the smallest Y value here. And what did they say set it at? Whoops, wrong way, Thomas. It did. Oh, where it changes by 1. Why do you want it to change? Why do you want your X values to change by 1? Why not a half or 0.25? Because we're building whole units. So we're not building 1.5 units or 10.5 units. We're building whole units. And so that's why they say changing it, your X values change by 1. And so once you do that and you start scrolling through the X values, you go through until you see where it starts going, it's decreasing, right? So here, and then going down, it starts, as X increases, the Y values are decreasing. And so you find out where it changes direction in the Y values. You have Y values coming down, and then all of a sudden they start going back up. So what's that X value right here where it stopped going down and now it's going up? And that's what this is talking about. So at 37 units, the cost per unit is at its smallest value. So we would want to manufacture 37 units a day, so it minimizes our cost on a daily basis. All right. Basically, what we covered here is the graph of a function is a collection of points x, y that satisfy the equation. And in most cases, it's a curve of some kind. Okay. So the curves can be of different shapes and doing different things. Okay. They just don't come back on themselves because of the vertical line test. Okay. And I'm going to stop here. So we've covered 2 sections so far. You need to be in MyLab. Hopefully you're done or almost done with 1.1, and you possibly have already started 1.2. And so by the time class comes around next Tuesday, you should have completed 2 sections. Census date is next Wednesday. So what census date does, it sets the size of the class. And if you decide you don't want to continue with any of your classes before census date, on or before that date, you can drop the class without any penalty. That means you get your entire tuition back, and it doesn't go towards the 6 drop limit. If you drop after census date, it will cost you money. That means you don't get as much money back from the tuition. And it's on a sliding scale. So the closer you get to the last day to drop, the less money you get back of your tuition. What else? And then it might, depending upon your situation, it could count as one of your drops. And you're allowed up to 6 drops. And the 7th drop, you pay out of state tuition, or out of area tuition. I don't know if it's out of area or out of state. I don't know. There's a difference. If it's at a university, it goes to out of state tuition, which is much higher rate. Okay, I'm done with y'all. Go away. Enjoy your weekend, but do your math homework. Okay. If you have questions, you can ask questions. I'll hang around for that. If you don't have any questions, then I'll see you next week. Come back in one piece. Don't take any wooden nickels. Shows you how old I am. Actually, that was old by the time I started hearing it. Okay. Serena and Isaac, I'm gonna go ahead. Oh, Isaac's gone. And Serena. Oh, I need to stop the share because I'm being selfish. I say that all the time.